Hi, I'm Simon Das and I'll be demonstrating some of the data management features of SOLIDWORKS PDM and the benefits they can bring. It's probably true that designers and people involved in the design to manufacturing process can spend hours every week on non-value-added file management activities. These activities usually involve manual processes for filing away, moving or renaming, and importantly finding again CAD or other product-related files, assuming there aren't duplicates or they haven't been deleted. On top of that, there are usually manual tasks around design approvals, exporting data to other formats, and filling information into downstream systems. We find a lot of these activities are manually tracked and communicated verbally or by email, so approaching a data management process or activity can be time-consuming. This presentation will highlight how SOLIDWORKS PDM can help you tackle some of these activities. Before we answer what is SOLIDWORKS PDM, let's start with what is PDM. Product Data Management, or PDM, is a system that allows your company to consolidate information in a secure vault. Any information that is part of the design to manufacturing process can be included, such as CAD files, QA documents, quotes, specifications, pictures, videos, letters, emails, and more. Whether you're creating mechanical or electrical design data, technical illustrations, or running simulation studies, SOLIDWORKS PDM is designed to manage the data created for the design to manufacturing process. This presentation centers around Acme, a general engineering company that design and make all kinds of products. Bob, a designer, and Jim, his manager, both use SOLIDWORKS PDM. In 4 short demos, you will see how Bob and Jim use SOLIDWORKS PDM to create data required for a new wrench design, plus its design approval. How PDM helps them to manage the revision to an existing design. How they view and process bills of materials for various products. And finally, how they manage more kinds of design-related files that Acme create. In this first demo, we will see the SOLIDWORKS PDM user experience, how new project folders and files can be created with PDM templates, and finally how an approval process can be used in PDM. SOLIDWORKS PDM uses a familiar Windows File Explorer to present the managed files. The blue icon on the C drive is the entry point into PDM, and once logged in, the File Explorer interface changes to show the content of the PDM vault. The file list splits into 2 panes, with files still listed in the top pane and information about any selected file in the bottom pane. Also, notice the folders are green. This indicates you are in PDM and working online. Browsing PDM is easy, just the same as File Explorer. However, with PDM you'll see much more information about the files listed, such as lifecycle status, drawing number, and description. When files are selected, tabs in the bottom pane will show the information about the selected file. For example, you can view a thumbnail image in the Preview tab, but when I click on the thumbnail, PDM will load the appropriate viewer to show the file with more fidelity. For SOLIDWORKS files, eDrawings is loaded right inside File Explorer, allowing you to rotate or pan the model, but also preview the configurations designated for viewing. This allows anyone with PDM to view the files that may traditionally have required the CAD system to view. On the Data Guard tab, you can see information or properties for the selected file, such as description, material, and finish. Again, this information is normally locked away in the file, but is now made visible with PDM. These properties can be useful for searching PDM as well as showing in Bill of Materials. On the Bills of Materials tab, PDM shows BOM structures and data related to SOLIDWORKS assemblies. More on that later. The Contains tab shows how files are related to each other, typically top-down parent-child references, such as between SOLIDWORKS models, but also drawings. The Where Used tab also shows how files are related, but this time bottom-up, for example, which assemblies a part is used in. Useful to know if a change is required on that part, as that change could impact multiple other designs. SOLIDWORKS PDM is great for CAD data management, but it can also be used to manage and control other product-related files of various kinds. They can be emails, images, standard Office files like Excel and Word, PDFs, plus SOLIDWORKS Composer files, that document downstream processes, such as assembly instructions. With that brief introduction to the user experience of SOLIDWORKS PDM, let's start the data creation process. A way to ensure everyone using PDM creates information in a consistent way is to template the process. For example, 2 project templates are available for creating folders, with each template configured for different options. Bob picks the general project template, which asks for 2 inputs, end customer and project manager. The template creates a set of standard folders to store project files, also copies the captured input, and even numbers a project folder to the next available number in the sequence. Using the same concept of templates, Bob can start the design of a new wrench handle in PDM. The data card for the new SOLIDWORKS file appears with some data already completed, like document and drawing numbers, but the description can be typed, and any additional properties can be set to help categorize the type of component. The empty file opens in SOLIDWORKS, and Bob is ready to start designing. Fast forwarding to the end of the modeling stage, the design has all the features and configurations required. While modeling, the file was checked out to Bob, so that only he has write access and no one else can mistakenly overwrite the work. It's worth highlighting that SOLIDWORKS PDM is tightly integrated into SOLIDWORKS CAD. The PDM task pane inside of SOLIDWORKS brings key PDM functionality into the design environment, functions like checkout, check-in, data cards, where used, and more. We'll look at some of these as we progress. The next stage is to ready the drawing for manufacture. Again, let's jump ahead to the completed drawing, which is also checked out like the model. With both files ready for approval, they can be checked into PDM using the task pane, with an option to add comments. Checking in files creates new versions of those files in PDM, allowing you to maintain a full history of the design. After the check-in, the files become read-only and shared with the team. For future edits, the files would be checked out, and a subsequent check-in would create new versions with the original versions maintained. Using the task pane, Bob can now transition the files from a working process state to the pending approval state using the change state command and selecting the submit for review transition. Bob picks Jim to notify about the change of state. For context, the workflow diagram being shown is how the approval process is configured for Acme's CAD files. It has 3 states and multiple transitions. Each state controls who can edit or view the data in that state. For example, the working process state would only allow the engineering team to view and edit the CAD files, and the files will be invisible to other departments until they reach the release state. The task pane updates to show the new state of the selected document, and if we zoom into the drawing's title block, you can see the user initials and date are automatically populated by PDM's workflow automation, saving Bob work and time. With that done, we now switch over to Jim's desktop to see his part of the process. After logging in, Jim receives a notification. When opened, the notification lists the files that were transitioned, their date and time, and Bob's comments. The notification contains links to files in PDM. For example, clicking the View links opens the files in eDrawings, where Jim can inspect and review the drawing and model data, plus its configurations. Once reviewed, the folder link in the notification opens the folder in PDM without Jim having to browse for it manually. As Jim is satisfied with the design, he can change the state of the SOLIDWORKS files from pending approval to release. Like Bob, Jim comments and proceeds with the state change. SOLIDWORKS PDM sets the next revision on the files, showing it on the data card and in the revision column of the file list. For Acme, when a drawing is released, a PDF should be created for downstream use. SOLIDWORKS PDM can save time and automate this process using a task. In this case, the task is part of the workflow transition, with Jim's PC set up to host the task. SOLIDWORKS starts automatically and converts the drawing to PDF, saving it back into PDM in the PDF folder. Taking a look at the PDF, if we zoom into the title block, you can see Jim's initials and a date, both populated into the CAD drawing by PDM's workflow automation. Summarizing the demo, what you saw was the easy-to-use experience of SOLIDWORKS PDM with its integration into Windows and the SOLIDWORKS CAD, minimizing the learning curve. You also saw how data is quickly created and organized with templates that can reduce manual steps and potential errors. And finally, you saw how SOLIDWORKS design data can be checked and approved with workflows, notifications, and automated tasks, improving manual processes. Let's have a look at making a change to a design after a problem is found. In this demo, we will see how to search for data, how to analyze where it is used, and how information about a revision can be audited after a change. Earlier, we saw how files can be found by browsing folders in PDM. A more powerful way to find data is through the search tools like Quick Search or search forms. In this example, Bob has been given a part number that has a problem. He receives this information from a PDM notification related to an engineering change order document or an ECO created earlier by Jim using a PDM template. To find the problem SOLIDWORKS file, the Quick Search bar is used, and after entering the number, the results are returned directly back in the file list. Quick Search can be configured to include different properties as well as file names, and to search in different folders. For more advanced search options, search forms can be configured and used. Search forms allow search results to be saved for later reuse and sharing. Once found, the part can be inspected. Selecting the SOLIDWORKS file brings up its properties in the tabs. The Preview tab allows the model to be viewed and measured in 3D. Importantly, Bob needs to find if the part is used anywhere. With the Where Used tab, he can see the part is used in an assembly, so both need to be edited, plus any related drawings. You can see the model is released, so a state change will be required before it can be edited. Bob opens the assembly in SOLIDWORKS, and with the interference check, he can see the problem with the handle and the shaft not fitting. As he is starting to modify the assembly, SOLIDWORKS PDM reminds him that the changes will only be saved if the file is checked out. He changes the state on all the files that need to be edited, and after a checkout, he is ready to change the design. Fast forwarding to the end of the CAD work, the changed models and drawing are checked in and are ready to be approved. Jim will be sent the notification as part of the state change, with the comment referencing the ECO number. To make it easier for everyone to see the relationship between the ECO and the changed assembly, Bob uses copy and paste reference to link the two files together. building a reference and an audit trail between CAD data and the governance data. This ensures anyone using PDM can visually see all the related files in the Contains tab or the Where Used tab. Using the History command on the locking handle, anyone using PDM can review all the events that happened on that file, when they happened, and with the comments why they happened, providing a useful audit trail. Summarizing the demo, what you saw was the quick and powerful search tools of SOLIDWORKS PDM that help reduce time looking for data. You also saw how the Where Used function can enhance your decision making when understanding files impacted by a component change. Lastly, you saw how additional workflows in PDM for engineering change, linking files, and viewing history help to ensure design change compliance. In this next demo, we'll look at how bills of materials, or BOMs, derived from SOLIDWORKS files can be viewed in PDM, how differences in BOMs can be compared, and how BOMs can be exported for downstream use. The Bill of Materials tab in SOLIDWORKS PDM displays BOM lines and columns of data, both extracted from the SOLIDWORKS assembly on check-in. Being able to see the BOM in PDM is useful for anyone needing to understand the makeup of a product without requiring the CAD system to view the structure. SOLIDWORKS PDM allows for multiple column sets for the display of BOMs, allowing more relevant data to be visible in the BOM depending on the requirements of the user or department. For example, the Manager BOM, which is only available to Jim, includes the material column. Thumbnail images help identify what the components look like, and selecting the sub-assemblies in the tree pane filters the main table to show only their components, again making it easier to inspect the data. When the SOLIDWORKS drawing is selected, you can see that a BOM table already exists on the sheet. It's not straightforward to see the content of the BOM in the preview, so a better way would be to switch back to the Bill of Materials tab and then select the drawing's BOM from the list. Again, this allows anyone to view the columns and contents of the table exactly as it's organized in the drawing. Another kind of bill of material PDM can display are cut lists. These are usually found in SOLIDWORKS weldment parts, like this frame for a barbecue grill. PDM shows two types of weldment table: the weldment cut list, which shows the cut lengths and quantities for each component, and the weldment BOM, which lists each component in the weldment part with its total length. This weldment information can be further verified using eDrawings and its measuring tools, useful for anyone without access to the CAD system. Another common task for anyone dealing with BOMs is working out what the difference is between two assemblies. This may be for different revisions of the same assembly to see how it's changed, or to see the difference between two product configurations of the same assembly. In this example, the tool vise was revised, and with the compare option used on the two revisions, it quickly and clearly shows each cell color-coded to indicate if components were either new, modified, or deleted. Traditionally, this might have been done by printing off the BOMs and then comparing them line by line. Sometimes the BOM data needs to be shared or read into other systems. A quick and simple way to do this is using Open a CSV file in the Bill of Materials tab. This opens the current BOM in Excel, allowing for any extra formatting or editing. This Excel file can then be shared with other users, departments, or systems. In this demo, you saw how BOMs can easily be viewed and compared by any PDM user, improving the communication of mechanical BOM data, and how duplicate data entry could be reduced by exporting BOMs from PDM for other downstream systems or processes. In this final demo, we'll look at how to add existing SOLIDWORKS CAD files and legacy DWG files into PDM, plus how to add and edit Office files in PDM, and finally how to access SOLIDWORKS PDM with a web browser for lighter editing or viewing use cases. Adding files into SOLIDWORKS PDM is as simple as saving into a PDM folder, copy and paste, or drag and drop. Let's take this existing folder of SOLIDWORKS files and add it to PDM using drag and drop. During the copy process, PDM is looking for file properties in the added files, as well as file references such as assemblies and their related components. Once added, the files are checked in, allowing you and others to see the information in PDM using the tabs. Similarly, we can take the folder of DWG files and copy and paste them into PDM. Again, on check-in, PDM will show how files are related, and when checked in, we can see previews and structures that weren't easily accessible outside of PDM. Product and design data is not just CAD files, so working with Office files and other formats in PDM can be just as important. This barbecue grill has accompanying documentation which is currently outside of PDM. We'll use the drag and drop approach again to add these product-related files into PDM. Once added and checked in, we can preview the data directly in PDM without opening the files. One of the added documents needs editing, so a simple right-click menu command checks out and opens the file. In this example, an exploded view of the grill is inserted into the document by searching PDM directly inside the Insert window in Microsoft Word. After laying out the page, the document is saved. The integrated SOLIDWORKS ribbon brings familiar tools like checkout and check-in to the user, ensuring the changes are captured and managed in PDM just like CAD files. Being managed in PDM allows previous versions of the document to be viewed, providing a way to see the evolution of the document. There are times when the person viewing or approving files in SOLIDWORKS PDM doesn't need the full PDM client in Windows or the CAD or Office PDM integrations. For those users, PDM can be accessed using a web browser. SOLIDWORKS PDM's Web 2 interface allows for browsing of folders when looking for files, as well as a simple and quick search tool. Once data is found, it can be viewed, whether it's a PDF document or a SOLIDWORKS CAD model. For SOLIDWORKS files, the Web 2 interface can show you a thumbnail image preview, the data card properties, history, and more. The preview can also show SOLIDWORKS files in more detail by getting eDrawings to convert the data into a lightweight format that's viewable in a web browser. For this wrench, we can see different configurations once converted, plus we can rotate the model to gain additional clarity. In this demo, you saw how common CAD and Office files can be quickly added into PDM, ensuring all your product data is centralized. How important documentation changes can be improved with a dedicated Office integration, and how data in PDM can be easily accessed in a web browser by all people involved in the design to manufacturing process. SOLIDWORKS PDM allows your company to consolidate information in a secure vault. Whether you're creating mechanical or electrical design data, technical illustrations, or running simulation studies, SOLIDWORKS PDM is designed to manage any information that is part of the design to manufacturing process.